Okay, this is the next topic, that is programmable logic array. So in the case of programmable logic array, we have two types to study. One is programmable logic array and programmable array logic. So in the case of programmable array logic, as you can see here, the first part, this is something like a NOT gate, but the difference is here, this is called as buffer input. This is called as buffer inverter. Means here, as you can see, this is buffer. We have two types. For example, consider this. This is a buffer. If I send an input as 1, output will be 1. If I send input as 0, output will be 0. For this buffer, we have something called as an invert. That is, this is called as a buffer invert. That is, if I have this triangle along with the circle, means one will be A and other one will be A bar. Both this buffer NOT gate, it acts as both complementary and without complementary. Instead of putting one with NOT gate and one without NOT gate, here directly they have taken this buffer inverter gate which does the both operation, that is A and A bar. As you can see, A and A bar. Similarly, we have B, B bar, C and C bar. Consider here we have a 4 AND gates here, 1, 2, 3, 4. For example, we have a function like this. Function is AB bar plus AC plus A bar BC bar. This is nothing but what? Function F1. Now concentrate on function F1. What is first function? AB bar. First, if you want to see, this is A. From A, here I have taken, put it as a star. Then B bar. Where is B bar? This is B bar. Where we have a circle, this is nothing but a B bar. This is nothing but first AND gate. First AND gate refers to these are nothing but a product terms, as you can see. The function F1, it has how many product terms? 3 product terms. So, first is AB bar. Then we have a AC. Then we have what? AC. This is A. And then C. And then we have a bar, B bar, C at the last. So all these three, that is AB bar plus AC plus A bar BC, are connected to one function called as a F1, as you can see. So coming to the next, F2 AC plus BC. For now time being, this bar neglected. We have AC and BC. So as you can see, we have A, C, and next is we have a BC. So this AC and BC are connected to the another one OR gate. For example, if consider this to be function 1, this is to be function 2. The concept of programming logic array is both the inputs of a AND gate and the inputs for a OR gates. This is the input for a AND gate, this is the input for a OR gate. Both are stars, means what? Both will be changing. Both are programmable. Both are not fixed. So the concept is both will be changing accordingly. So this is function F1. This is function F2. How I got function F1? If you see, notice this star mark. AB bar plus AC plus A bar, B bar, C bar. This is function F1. Similarly, F2 is AC plus BC. Leave this bar. We'll see this how to do. Since here the function F1 is without bar and function F2 is with bar, so here we are implementing another type of a gates called as Xor gates. So first is Xor gate for function F1, Xor gate, again for function F2, Xor gate. Here which function has bar for us? F2 has bar. So since F2 has bar, I am putting here bar for F2. Wherever you have complementary, put it as 1. Wherever without complementary, put it as 0. So this is function F1, this is function F2. So 1 means complementary, 0 means no change. If it is 1 means, then it means the function is complementary, or it can also be written as like this bar. AC plus BC bar. So function is, so I am going to repeat once again. First and the foremost, we are going to use a buffer inverter which does both the operation without inversion and with inversion. First, concentrate on two functions. They may give any of the functions to implement. You need to do the same. They may give, here I have taken 2 functions. They may give 3 to 4 functions. So based on the functions given, for example, think something they have given as A, B, C, D also. So you need to consider here D and D bar. So since here first concentrate on F1, first is we have a AB bar, first concentrate on the first AND gate, A, B bar. Next we have AC, next we have A bar, BC. All these three will form a function F1. Then rest 2 will be in function 2. Since here we have a complementary in function F2, so take it as a 1 for F2. Take it as a 1. 1 means complementary, 0 means without complementary. So that was about the diagram. Coming to the next PLA programming table. Here we have basically three of a section. One is product term section, input section, third is the output section. So how many product terms we have here? As you can see here, function F1, A, B bar, AC, A bar, BC. Then AC is already present here. AC is already present here. Then we have a BC. Next is A bar. Next is A bar, BC. So first is A, B bar. Next is AC, second is BC. So finally we will be getting here at the last function F1 is AB bar plus AC plus A bar BC. F2 is AC plus BC. When we consider all these things, we will be getting this table. So this is the product terms, as you get 4 product terms. Product term 1, 2, 3 and 4. Now see here in this AB, what we have A means put it as 1. Next we have what? B. What we have in place of B, whether we have B or B bar? B bar. B bar means C. Next C. Do we have any C here? No. So put it as dash. Similarly go for now AC. Put A1 and C1, B as dash. Next BC. Put these two as 1, rest as dash. Next is similarly A bar, B, C bar. A bar, B, C bar. Wherever you have A means put it as 1. A bar means put it as 0. If it is missing, put it as dash. Now coming to this, we have got this. Coming to the output, concentrate on function now. Function F, we have something called as 2 columns here. One is true and another one is complementary. As you can see in the diagram, one is what? Complementary. 0 is without complementary. It is like this is complementary, this is true. That is function F2 is what? Complementary. Function F1 is true. So function F1 means, which are function F1? This is function F1. This is function F1. This is also function F1. That is A, B bar, put 1, 1, dash and 1. Next similarly for F2 what we have? AC plus BC. AC plus BC bar. Complementary means what here? It is bar. So this is nothing but a programmable logic array programming table. So PLA in general, if it has n inputs, k product terms, these are product terms, and m outputs consists of n buffers, buffer input gates, k AND gates, m OR gates and m XOR gates. Here we have so many of a gates, as you can see. First and the foremost, inverter gates. Something we have a AND gates. Then we have 2 OR gates. Then we have a XOR gate. I am going to repeat. This AND gates, the input is from the main input, which represents the changing input, and the output, which represents the changing output. And here we have a XOR gates at the bottom to decide whether the function is complementary or it is without complementary. For more explanation, you can refer the PPTs.